You're standing in sunlight. Your shadow falls on the ground. Sharp edges, dark shape, perfectly predictable. You move, it moves. You raise your hand, it raises its hand. And you think you understand what's happening. You think light travels in straight lines, hits your body, gets blocked, creates darkness on the other side. Simple geometry, simple optics. But here's what Richard Feynman spent years trying to tell anyone who would listen. Your shadow shouldn't exist. Not the way it does. Not with those sharp edges. Not according to the actual laws that govern light. So why does it? And what does the answer tell us about how deeply broken our picture of reality actually is? Let me tell you something. We teach physics backwards. We start with the easy lies and hope you never ask the hard questions. We say light travels in straight lines. We say particles have positions. We say the universe is made of things moving through space, and if you know where everything is and how fast it's moving, you can predict what happens next. This is Newtonian physics. This is the clockwork universe. And it works beautifully for shadows and baseballs and planets. It works so well that we spent 300 years thinking it was true. But it's not true. It's not even close. And your shadow is the proof. Stay with me, because this gets strange fast. When light leaves the sun and travels to Earth, we imagine it as rays. Straight lines shooting through space at the speed of light. And when those rays hit your body, the solid matter blocks them, and the blocked region creates a shadow. This picture is so intuitive, so obvious that we don't question it, but Feynman did. And when he looked at the actual mathematics of how light behaves, he found something disturbing. Light doesn't travel in straight lines. It doesn't travel in any lines. It travels in all possible paths simultaneously. And the shadow you see is the result of those paths interfering with each other in ways that shouldn't produce sharp edges, but somehow do. Here's the experiment that breaks everything. Take a laser pointer and shine it through a tiny hole onto a wall. You'd expect a tiny dot of light, right? Just the rays that made it through the hole, traveling straight to the wall. But that's not what happens. You get a bright spot in the center, yes, but around it you get rings, alternating bright and dark circles spreading outward. This is called a diffraction pattern, and it's not supposed to be there. If light traveled in straight lines, there would be no rings, just a dot. But the rings are real. You can photograph them, and they tell us something shocking. Light that went through the hole somehow knows about the edges of the hole. It bends around them, it spreads out, it interferes with itself. Do you see what happens? The light didn't take one path through the hole. It took every possible path. Some paths bent left around the edge. Some bent right. Some went straight through. And when all those paths arrive at the wall, they add up. Where the peaks of the waves align, you get brightness. Where peaks meet troughs, you get darkness. The pattern you see is not light traveling. It's light exploring every option and then interfering with itself to create what looks like a definite path. If you want to understand how the universe actually works, not just how it looks, but how it works, hit that subscribe button. Let's find things out together. Because this is where your shadow comes in. When sunlight hits your body, quantum mechanics says the light should be exploring every possible path around you. It should be bending, spreading, creating interference patterns at your edges. Your shadow should be fuzzy. It should have rings of brightness and darkness rippling out from the boundary of your body. But it doesn't. It's sharp, clean, exactly what Newtonian ray optics predicts. So what's happening? Is quantum mechanics wrong, or is something else going on? The answer is both beautiful and terrifying. Quantum mechanics is not wrong. The light really is taking every possible path. But most of those paths cancel out. Here's how. Imagine light leaving the sun and trying to reach the ground beside you. It could go straight there, never hitting you at all. That's one path. Or it could take a crazy detour, looping miles out into space before coming back down. That's another path. Quantum mechanics says both paths happen. The light explores both options. But here's the trick. The crazy looping path takes much longer. By the time that light arrives, it's out of phase with the light that took the straight path. The wave peaks don't line up anymore. They interfere destructively. They cancel. And when you add up all the infinite possible paths, the only ones that survive are the ones close to the straight line, because those are the only ones that take similar amounts of time and arrive in phase with each other. This is Feynman's path integral formulation of quantum mechanics. Light doesn't choose the straight path. It takes every path, and the paths interfere until only the straight one remains visible. Your shadow has sharp edges not because light travels in straight lines, but because all the bent paths destroyed each other. The Newtonian picture is the ghost of quantum interference. The clockwork universe is what's left after the waves collapse into something that looks classical. Let's be honest about what this means. Nothing actually travels from the sun to your shadow. There is no photon with a definite trajectory. There's a probability amplitude, a complex number assigned to every possible route light could take. And when you square those amplitudes and sum them up, you get the probability of light arriving at any given point. The light is everywhere and nowhere until it arrives. It exists as a superposition of all possible histories. And only when you look, only when the light interacts with your eye or a detector or the ground, does it collapse into something that looks like it took a single path. But here's the part that breaks people's brains. If light works this way, then so does everything else. Electrons take every possible path between atoms. Molecules explore every configuration simultaneously. And you, your body, the arrangement of particles that makes up what you call yourself, you're not taking one path through time, you're taking all of them. Right now, there's a version of your story where you moved your hand slightly differently 5 seconds ago, a version where you blinked earlier, a version where a single neuron fired in a different pattern. Quantum mechanics says all these versions exist in superposition until something measures them, until the wave function collapses, until the interference destroys all but one observable history. This is the part that keeps me up at night. If you're a superposition of all possible paths through time, then what collapses the wave function? What decides which version of you becomes real? In the laboratory, we say measurement does it. An observer looks and the system becomes definite. But you are the observer. You are also the system. So who's measuring you? What's collapsing your wave function into the single timeline you experience? And if nothing is, if you're still in superposition, then the person you think you are is just one term in an infinite sum of possible yous, all equally real, all interfering with each other in ways you can't perceive. Now I want to take this deeper, because the shadow is just the beginning. Feynman's path integral tells us that particles don't have trajectories between measurements. They don't have positions. They don't exist as little balls moving through space. They exist as fields, as waves of probability, as mathematical objects that only become particle-like when we force them to interact with something. And the universe doesn't care which interpretation you prefer. The math is the same. The predictions are the same. But the picture of reality underneath is shattered. This is what Feynman meant when he said nobody understands quantum mechanics. Not that the equations are hard. They're not really. You can learn to calculate interference patterns, predict electron behavior, design computer chips that exploit quantum tunneling. But understanding what the math means, what it's telling us about the nature of reality, that's where we fail. Because the math says there are no things, no particles with definite positions moving along definite paths, just waves of probability interfering with each other until something we call measurement forces them to pretend they were particles all along. And the measurement problem is still unsolved. We don't know what counts as a measurement. We don't know why the wave function collapses. We don't know if collapse is even real or if the universe just branches into parallel versions every time a quantum event occurs, each version seeing a different outcome, all of them equally real, forever splitting into more and more copies of everything that could possibly happen. This is the many worlds interpretation, and it's mathematically simpler than collapse, but philosophically insane. It says your shadow exists in one branch of reality, while in another branch, the light bent differently and your shadow is slightly offset, and in another branch, you never stood in that spot at all. Let me bring this back to something concrete. Right now, photons from your screen are hitting your retina. Those photons took every possible path from the screen to your eye. They went straight. They bounced off the walls. They looped around your head, all of it. And the paths interfered until only the near straight ones survived. Your vision, the image you're seeing right now, is the result of quantum interference destroying most of reality and leaving behind the thin slice that looks classical. You think you're seeing objects in space. You're actually seeing the interference pattern of probability waves that explored every possible configuration of the electromagnetic field and canceled themselves down to something your brain can interpret as light and color and shape. This is not how we experience the world. We experience sharp shadows and definite positions and objects that stay where we put them. But that's not what's there. What's there is a vast space of possibilities, most of them interfering destructively, a tiny fraction surviving to create the appearance of a classical universe. And the question Feynman never answered, the question that still haunts physics, is why? Why does interference happen? Why do the paths cancel? What is the mechanism that turns infinite quantum possibilities into the single definite world we see? Nobody knows. We can calculate it, we can predict it, we can build technology around it, but we don't understand it. And your shadow, that simple dark shape on the ground, is proof that our fundamental picture of reality is missing something enormous. But here's what Feynman also understood. The brokenness is not a flaw, it's a feature. The fact that quantum mechanics doesn't make sense to our monkey brains is not a problem with quantum mechanics. It's a problem with our brains. We evolved to survive on the African savanna, not to understand the foundations of reality. We evolved to see sharp shadows and trust them. And the universe doesn't care what we find intuitive, it does what the math says. And the math says reality is far stranger, far more fluid, far more ambiguous than any story we can tell ourselves. The shadow is sharp because the fuzzy paths destroyed each other. The universe looks classical because the quantum noise interfered into silence. And you, the observer, you're part of the interference pattern too. You're not outside the system looking in. You're a term in the wave function, collapsing and reforming, exploring every possible configuration of neurons and thoughts and decisions, and only experiencing the thin slice where everything adds up constructively. This is the warning Feynman kept giving. Don't trust your intuition. Don't trust the simple story. The universe is not made of things. It's made of possibilities that interfere. And the world you see is just the shadow of something much larger, much stranger, much more beautiful than you can hold in your mind all at once. Your shadow proves the universe is broken. Or maybe it proves we were never looking at the right universe to begin with. Maybe the broken thing is our insistence that reality should make sense in words, in pictures, in stories with clear beginnings and endings. Maybe the universe is doing exactly what it's supposed to do, and we're the ones still catching up. Shadows are sharp. Light bends anyway. You exist. You're also a wave. Nothing is certain. Everything interferes. And somehow, against all odds, the interference creates you. If this twisted your brain a little bit, good. That means it's working. I'll see you in the next one.